So welcome back to the technology track of Project Reclass's very first hack day. Again, I'm Tay, I'm the co-founder, and now we finished talking about software. Now we're going into infrastructure. So how do we deploy this stuff? We'll talk a little bit about why we chose Docker as our main container for everything, and I will hand it off to Scott.
Yeah, so one of the issues that we had was making sure that our application would run the same on the person who is going into the prison's computer as it would run on the servers that they are deployed to, as it would run on a developer's computer. And one of the solutions that we came up with was Docker. Because Docker is platform agnostic, it's much smaller than a VM, and because it's also much smaller, it starts up much faster than a traditional VM. We decided it was a great choice. Next slide. So as I just mentioned, containers are a lot smaller than virtual machines because they don't have the kernel attached to them. So they start up much faster than a traditional VM, but we still get that same benefits of a virtual machine of being able to run it the same way in any environment, whether that's on somebody's computer, on the server, or on a developer's environment. Next slide. And so because we use Docker, with both of our backend services and our front-end service, we are able to use Docker Compose to start up both of the services and connect them. This makes it really easy, especially in a development environment when we don't want to have to worry about setting up the backend. So all we have to do is run Docker Compose up, and it actually uses GitHub's repository, the GitHub repository for the backend if you're developing for the front end, starts up the Docker container and connects the front end for you. This also makes it really easy to test pull requests because you can change the pull request ID in the Docker Compose file to point to the newly created pull request. And we just run Docker Compose up build again after modifying that, and it starts up both the front end and the back end and allows us to test that. Docker and Docker Compose also allow us in the future to branch out and use many different services. Like in the future, we will probably have a service that handles the Mininet clusters for us. And because we're using Docker and Docker Compose, it creates this abstraction for developers that makes it very easy for us to start up, stand down, and just, again, ensures that it's going to run the same on any platform that we run it on. Next slide.
Okay, so that was to get Toynet into prisons. However, we mentioned that we do want users on the World Wide Web, and that is a slightly more complex problem. So right now we are using Elastic Container Services by AWS to deploy React and Django. Currently, we only have one instance of each up, though as we need to scale, we'll likely expand on that. They each have one container in them for now. However, this setup is not going to work for Mininet. The reason being that the way Mininet works is it creates files that represent either the interfaces and all of the devices, and they are named, the files are named after the name of the device. So if you had a interface on a switch, it might be S0-ETH0. And if there's too many nets running with the same switch name, they're actually going to collide and one of them is going to fail to create a switch. So we wanted a way to make sure that the different mini nets running on the same compute do not disturb each other. One way that you could do this is to add a randomly generated integer to each name based on which session you're talking about, but that requires us to go into the Mininet source code. And for now, we're preferring, hopefully it is cost effective. Right now, we're thinking to instead have containers for each Mininet instance, even if we only have one container for Django servicing hundreds of clients, we would still have a separate Docker container for each Mininet instance. That means that we need a more scalable deployment infrastructure because ECS is fairly expensive, it's managed. So we are looking into Kubernetes actually in Q4 to limit the size of each compute and to orchestrate many of them so that as of course we get famous and everybody uses us from all of the schools, all of the prisons, and all of the anything, we have the capacity to do so. There's a even finer concern with respect to latency. When I bring up a Mininet instance on my local laptop, it actually takes more than 10 seconds. And if you're a web developer, you know that humans can perceive anything over half a second. And the average attention span of a user is 8. After that, they get very frustrated. Even if you finagle the load and things, there's only so much they're willing to wait. Therefore, we'd like to anticipate the next user and the next user. If we had 10 containers up and we are anticipating an 11th or a 12th, we want to start spinning that up ahead of time. At the same time, we don't want to waste too much money, so we want to make sure we're cleaning that up as we go. Are there any questions on that piece before I talk about the developer workflow?
So I was a little bit curious about what you meant when you said Kubernetes for Mininet here. What is that? So I'm guessing when you say, as you mentioned before, so right now you're using ECS, and it sounds like you might be using Kubernetes to take over the entire thing, right? Not just the Mininet portion, but also running the Django container and the React or the server that serves up the React, that container.
Yeah, go ahead.
Okay, yeah. So I was wondering, sort of, maybe at a slightly lower level, how you imagine the Mininet portion of that playing out, and how that plays into latency concerns. Is it going to be sort of you have like a standby set of, I guess, pods that all are sort of going to get swapped in and out depending on how things go, or?
Yeah, that is what I'm envisioning, is that if we saturate a certain amount of the previous pods that are already up, then we'll bring up some more. And if multiple pods are idle for some period of time, then we can bring them back down to stay with the traffic. For React and Django, we don't have immediate need. So Kubernetes is an immediate need for Mininet because we don't have a cost-effective plan for onboarding users with ECS. In terms of converting the React and Django pieces to Kubernetes, we are not in as much of a rush because it's not costing us too much. And we have a $2,000 voucher from AWS for being a nonprofit. But we're trying to figure out what we're doing before we burn through that. So I'm guessing once we learn Kubernetes, we would apply it to React and Django. But it is a lower priority than getting just this Mininet piece to work. Does that answer your question?
Yeah, I think so.
Awesome. Any other questions? Okay. So we had some questions about, hey, how does the CI/CD pipeline look for us? So our GitHub repository is hooked up to a GitHub action that triggers on a merge. And what it does is it does a multi-stage build of a Docker container, meaning in our case, it is a lot cheaper for us to serve the static files involved in our React application than it is to build it in using npm because we have to install it and everything. So we actually copy just the static files produced from building a React application into a smaller Docker container. And then we want to publish that image to the Elastic Container Registry, which is Amazon's in-house way of managing containers, container images. And then that will tell us what image ID we're working with. Once we have that image ID, we can inject it into the AWS task definition that is used to bring up the Elastic Container Services, which is the managed fleet of containers that AWS uses. So that's where we're going to have a ECS cluster, two actually, one for Toynet and one for Django. And what we have is a load balancer in front of each of these clusters that routes to them. As I said before, we only have one instance so far, but we've put a couple different a couple different containers in the React one, and it's performed very well, which makes sense. And the user will hit the load balancer for the React, and the React application will then, it has, through Terraform, we actually tell it what the load balancer domain of the backend is, and it will communicate directly with the backend and serve information back to the user. Any questions on this slide?
Yeah, out of curiosity, why are you using 2 ECS clusters and 2 sets of load balancers?
So one way that we could have done this entire thing is for the 2 containers to be paired up. But, or like, even like it could, the Django could be coupled within the same container with the React. We did it this way partially just to learn what it's like to build load. This way we can just scale the React or just scale the Django. I believe we could have multiple services in one cluster. I don't know if, I'm looking at Theo seeing if he has a clue. I think we could probably have done both services in the same cluster. That was more just us bringing up clusters. And specifically what we do in our design is the back end is in its own subnet, and the front end is in its own subnet, and the back end subnet is private. So it cannot be accessed from the outside world. And we actually lock down the security groups to the point that only the port 8000 port is available for access. And then we do also lock down the public subnet for the React as much as possible. So a lot of it is just imagining, okay, if we were an enterprise with 1 million users, what would we do? Because we have this nice AWS credit. Any other questions? Cool. So this is what the workflow looks like if you come onto our team. Say you're a React developer, you would be working off of a feature branch, or actually, I think technically we're supposed to do forks, but you know, you make a PR later, you first have to code it up. And during that time, if you need the backend to test, then you're going to need to connect to a backend instance of Django. And we do that by allowing you to bring up a Docker container in your machine, and it automatically pulls the code from GitHub. Because they're 2 different repos, it automatically pulls the master branch of the Django repo and spins it up for you. So it makes development really easy. We thought about putting the React container inside of a Docker Compose, but Scott recommended against it because he felt that it was less responsive that way. And there's no point slowing our React developers down for that. So then once you have decided that you want to make a pull request, you will do so, and say Scott or I might want to review your pull request. All we would do is we would change some of the variables inside the Docker Compose configuration file, so that we pull your branch down and we can test it using Docker Compose. If we approve it, it is merged into our master branch, which we use for production. So at that point, that all merge GitHub action that we talked about earlier, it gets triggered and publishes to a registry, which means that a deploy is triggered to our cluster. So right now, if you merge a pull request into our React application, it automatically deploys to production. Any questions? Okay, and what is a GitHub action? Maybe I put this slide in the wrong place, but I'll leave it to Scott to explain.
Yeah, so as Tay mentioned before, we use GitHub Actions for our CI and for actually our CD too. And so part of our CI is we run our linting, testing, building, and our deploying in GitHub Actions. And all of those, except for deploying, need to pass before anything is actually merged into the master branch. So there's different checks that we have, and as long as they pass, then we know that you're good. We'll do the code review and make sure that everything looks good. But this basically is just us automating as much as we can of the code review process to ensure that there is no there is no going back on the stability of the code to ensure code quality, because that's one of the things that I am huge on, is ensuring that the quality of code is very high. And GitHub Actions has really been there to help us out with that. Next slide. Are there any questions on that? I know I kind of went through it kind of fast.
I'm gonna assume we're good. If you have questions later, just email us or something. Okay, so now we're going to turn it over to Theo to talk about infrastructure as code. So we want to spend as little time as possible finagling with like AWS components separately and making human errors. As Theo came onto the team, he was really an advocate for both security and automation. So I'm very excited to hear what Theo has to say.
Hello, everyone. My name is Theo. Like Tate mentioned, I'm going to talk a little bit about infrastructure as code. I am the infrastructure team lead here at Project Reclass, and I'm a systems administrator for the U.S. Air Force active duty. So next slide, please.
Hey, Theo. It looks like Toynet's actually down.
Toynet is down, like our
Yeah.
real Toynet. Can you
Yeah.
share your screen and show us? Let's see.
Sure.
Then, oh wow. Okay. We could have a couple other people go to the website and make sure it's not just Scott that's having a problem.
Should I go to the website?
Yeah, that would help.
Oh, Scott's there. That looks very suspect.
Okay, well, that's a problem.
Oh no, US one
All right.
flooded.
So, I was going to talk a little bit about Terraform, but I guess we get to do it live. I'm going to first clear the state. So let's demo this. And share.
Sudo cloud.
So the first thing that I'm going to do is clear our state by going to the branch and destroying all of our stuff. Terraform init. This is going to download all the modules for us to make sure that everything works. So we can actually run our Terraform destroy and take everything down. This will refresh the state for us, so we can hopefully reapply later. And then in the meantime, I will continue sharing the slides. So we'll stop this share, start a new one.
I looked into the issue further. It turns out that it's only affecting US West 1A availability zone and US West 1B availability zone, which are the two zones that we're deployed to.
Those are our zones.
No.
All right, well, that's okay. We'll have to change those when we can get back up here. Let's see. Can everyone see this? Oh, no.
I see a interestingly shaped window with.
Let me try again. Share.
Yeah, you might have to share the window. I guess Hurricane COVID came through and wiped out the AWS data.
I guess so.
Yes, this would happen.
Does this look better? Are these the slides?
Yes.
Okay, awesome. So as I was saying, Terraform is a tool from HashiCorp. It is an infrastructure as code tool. It allows us to automate our infrastructure so that we don't have to manually go into the GUI or the command line to stand up things like VPCs, EC2 instances, for example, for AWS, or any of the subnets. So Terraform has a provider resource relationship with their infrastructure. So they have about 344 providers, which range from anywhere between AWS, Google Cloud Platform, or just any community provided providers as well. And then a resource is going to be a resource is actually going to be the things that we specify. So if we specify a provider as AWS, and server, for example, would be the resource EC2 instance. And then here we have an XKCD about how important automation is. So you can see that we can save a minimum 5 seconds a year, or as many as 9 months per year. Awesome. So Terraform is pretty easily installed. I personally installed it on my Mac with brew install. That's my package manager. If you have Debian, for you, it's going to be apt. If you're on a Red Hat system, it's going to be Yum or DNF. If you're on Windows, you can install it via the website at terraform.io, or you can use Chocolatey if that's your package manager. And on. So now I'm going to do our actual demo for Terraform, which is building a website via Terraform. We're going to stand that up all by ourselves. So I'm going to go into my directory, and we're going to look at our main.tf file. So all of the .tf files are the Terraform formatted files. The main file is the one that runs by default when you run Terraform apply or plan or destroy. So we're just going to go over a few things here. The provider at the top is AWS. Our region is US West 2. Here's a resource. We're going to define a security group, and we're going to give it the name Hackday site. And we're going to actually allow all SSH and HTTP traffic, which is not ideal, but we're going to do it anyway, just to make sure it works. This is going to be accepting from any IP address on port 22 for SSH, and also accepting from any IP address on port 80 for HTTP. And then coming out of the server will be any protocol from any port from any IP address. Here's where we're going to actually define our AWS instance, and we're going to give it the name Hackday site as well. This AMI ID is just a basic Red Hat image. The t2.micro is the instance type, which defines the size for storage as well as RAM and number of VPC or number of CPUs. The security group is what we're going to reference from above, and we're going to give ourselves a key to make sure that we can actually SSH into our server and manage it. And then here we're going to input some user data, which is going to go into the server. It's going to install a few things. So this is going to install Apache. This is going to start Apache. This will enable it to make sure that it starts every time that the server is started up. And this is what we're going to input into our index.html file, which will define what actually shows up on our website. And then this tag down here is just saying that the name of the server will be Hackday website server. Do you have any questions on that? I know that was a lot of content. All right, so we're going to do a Terraform apply, but as I mentioned earlier, we have to do a Terraform init to make sure we get all of our modules. So Terraform is really helpful with their errors. It tells us exactly what's going on and how to solve it, or their suggested way to solve it. So I want to be sure to show that really quickly. So the initialization worked. We can run a Terraform apply again. And this is basically just going to go through everything that it's creating. Your plus sign here is creating new content. If it was the little squiggly tilde, it would be changing content. And if it was a red kind of minus sign or attack sign, it would be destroying content. So this is just going to create our instance. It's going to create a block device, some metadata. It's going to put it on the default interfaces and VPCs and subnets that we already have set up. And so we're going to say yes down here to our apply. And it's actually going to take a little while to come up. So we're going to go back to our EC2 instance and go, let's see. So we have to fix this really quickly. Sorry, everyone. We have to change our reason for the AMI, and then run the Terraform apply again. So this is why Terraform is so great, is because it's pretty simplistic in what it does and what it tells us when we do make mistakes. And then from here, we're going to actually go back and just check and see if anybody has any more questions on Terraform. Anything else related to HashiCorp?
Everyone get what Terraform is doing? Go ahead.
Oh, I was about to maybe kick that up as a question to tee up of, yeah, what's the difference between what the sort of infrastructure as code approach embodied by Terraform is doing versus how someone might normally go and set up these AWS resources, or for example use some other system like Puppet or Ansible or something like that?
Okay, yeah. So normally, right, you would want to, you have a couple of options of setting things up in AWS specifically. So you have the AWS command line interface where you can call AWS and set things up manually, or you could actually go and create it in the GUI. That is a little bit more time consuming because you have to navigate around, and then the command line interface also has a little bit of a learning curve. But in comparison to Ansible specifically, because I do have a little bit of experience with that, I would argue that Terraform is a little bit easier to manage. It definitely is a lot more clear in some of the problems that it runs into. I know if Ansible just can't get somewhere, kind of just errors out and tells you that it failed, whereas Terraform gives you a little bit more feedback on those error messages. Did that answer your question?
Yeah. I had one more that's maybe a little bit lower level, which is how do you imagine tying Terraform together with Kubernetes if that turns into a thing? I'm sort of available to, I think there's some Terraform Kubernetes integrations. There's a couple available, but I'm sort of curious if you guys have an overall strategy or whether that's going to tie into your choice of CI/CD. Like, are you going to stay with GitHub Actions, move to something else, maybe like JXBoot or something like that, that has more integrations along that end?
You know, Changlin, we haven't looked into that yet. However, I just started a job where everything I'm touching is Kubernetes. So I will get back to you in like 2 weeks with an answer. I am currently learning how to build pods.
Very nice, very nice, very nice. Yes.
Okay.
Good question.
To continue on.
Yeah, so right now I am just applying let me see if I can share it with you guys. We're just applying the toynet to try and bring that back up. But we first need to go in and fix the instances, the region that we had it in. So I'm going to go into our infrastructure again. And bring it back to Terraform.
I see a slowly scrolling Terraform output, which I'm guessing is
Yeah, so one of the things that I went ahead and did in the background, my apologies, was I went and I added in the regions for Toynet so that we could bring it back up on a different region. And so it's deploying all that now. I did want to get you guys input on how we should go about making sure that this doesn't happen in the future. So I do want to share this with everyone and try and see. Here we go. In terms of if anybody had any input on how to ensure that we don't lose all of our Toynet in the future by sticking in the same region, or where we would go to. So here we have a variables file, which specifies our regions and all of our other variables. This is the availability zones for Toynet. Do you have any suggestions on how to change that?
I guess we
or
could
what to do?
deploy to multiple regions if we want it to be super robust, because even if you deploy to different availability zones within the same region, if there's a natural disaster that is affecting the entire region, for example, a huge earthquake, then you would still lose all of your information at once. So maybe we should have considered deploying to like US East, for example, and not just US West.
Okay, that's a good idea. So you're saying we should probably change this to US East, maybe 2, send it to Ohio?
Yeah.
Okay.
Yeah, we probably don't have time to run that. Since we're
Right.
typing up soon, but yeah, I think that
So our Terraform apply did finish over here. Make sure that everyone can see that.
I made it at the URL of the load balancer, which is what we're gonna need to point at that project reclass.org to. I made it so that output's at the bottom. I can't quite see it on my screen right now, but if you copy paste that, eventually the React application should be up.
Okay, I'm seeing that right here.
Yay!
Can everyone see this? Great. So this is our new load balancer. Congratulations, everyone. Thanks for helping us get that back up. It's been quite the journey.